To keep weight down, the Abrams armor is thickest where a threat is most likely, on the front and on the turret. The sides have less armor, and the rear and roof are the least protected. In conventional warfare, that's not a problem. But in the close-up street battles of Iraq, insurgents with homemade bombs and rocket-propelled grenades have targeted vulnerable areas like the engine compartment. Scientists have developed new technologies to protect tanks and their crews in urban areas. When the fight turns to the streets, the rules change, and so does tank design. Engineers have developed a technology that fights fire with fire. To stop an enemy explosive shell from penetrating the tank and killing the crew, they have created their own explosion to drive the destructive energy of incoming rounds away from the tank. It's called reactive armor, a system that prevents shells penetrating the tank by literally blowing them away. It consists of a series of explosive flyer plates that cover vulnerable parts of the tank. The tank is literally covered in high explosive. The flyer plates look like small boxes. They contain an explosive that is detonated only when hit by a rocket or missile. On impact, the explosive ignites and pushes the force of the incoming projectile outward. Socorro, New Mexico, 10 a.m. And explosive expert Van Romero and his team are about to conduct a demonstration to show the protective power of this type of armor. As Vice President of New Mexico Tech, one of America's leading research centers for explosive science, Romero has been at the forefront of explosive technology for over 25 years. He's demonstrating how reactive armor repels armor-piercing shells.
What we're going to demonstrate today is the basic principle behind a flyer plate. And this basic flyer plate technology is used in all reactive armor.
In our first demonstration, Romero will fire a shell at standard armor with no reactive flyer plate. The team use a shaped explosive warhead, like those used in a rocket-propelled grenade, or RPG. The explosion is focused on the copper lining, creating a jet of molten copper that punches through armor.
We're going to have about 10 inches of armor, fire the warhead right next to that armor, and cut a jet through 10 inches of steel.
Five, 4, 3, 2, 1.
To the naked eye, it's all over in a flash. The only way to see what's happening is on high-speed cameras. At an incredible 10,000 pictures a second, we can see that the copper jet slices through the 10 inches of steel like a knife through butter. The superheated jet of burning copper instantly liquefies the metal in the armor as it punches in. It cuts through the armor at hypersonic speeds, up to 25 times the speed of sound. In a combat situation, this could have been lethal.
And then they exit.
The inner layers of armor would have shattered, sending shards of hot metal through the interior, striking the crew and probably igniting the fuel and ammo stores. Reactive armor is different. In the second demonstration, Van Romero sandwiches sheets of flexible explosive between a 1-inch block of steel and the armor, creating the reactive flyer plate.
As the warhead starts to cut through the outer metal and into the high-energy explosives, the explosives will ignite and push the flyer plate into the incoming jet. That will defeat the incoming round and protect the tank.
The idea is based on simple physics. The shock and the heat of the jet from the RPG coming in presses down on the high explosive and detonates it. This shoots the flyer plate out, and that pushes against the armor that's behind it. The combined pressure forces the explosive charge away from the tank.
Simple technology, but it works. And all reactive armor is kind of based on that simple principle.
3, 2, 1.
What's that?
Went boom.
It did, yeah. Good.
Once the metal has cooled, Romero examines the armor. The jet has cut a small hole in one side, but has not pierced the whole way through. The exploding armor is triggered by the initial impact of the shell. It blasts outward, neutralizing the effect of the impact before it ever reaches the inner layers of armor plate. High-speed footage reveals the astonishing difference between the armor that hasn't been protected and the one that has.
This jet is what gets into the turret of the tank and causes havoc with the crew and everything inside the tank. What we've managed to do with the explosive armor is eliminate that jet from getting inside. You see here, there's absolutely no jet. Well, you can see the shape charge perfect.
Big difference.
Yeah.
It's an astonishing technology, a simple reactive blast, but it's enough to completely block a superheated jet of copper traveling at 25 times the speed of sound.
All of the energy is being expended on this side of the armor, as opposed to the energy going through the armor and escaping into the turret of the tank. And so it worked perfect.
An RPG hit is severe, but without reactive armor, the crew would almost certainly be dead.
Even with this protection, it still is a pretty rocky ride inside that turret. It's no picnic when you get hit like that. You know it. But lives will be saved.
The real brilliance of reactive armor is that it saves lives and machines without adding very much weight. To do the same job with conventional armor would require 10 times the amount. But because reactive armor weighs around a ton, the tank stays light, fast, and maneuverable. Out in Iraq, reactive armor has already saved lives.
We did get hit with a couple of homemade RPG grenade type devices that it was more of a shock therapy for us, but it bounced off and we kept on rolling.
Reactive armor gives tank crews the edge in battle and the confidence they need to confront the enemy head-on.
You can sit there and you can feel a round bounce off of you, an RPG round. This item that is designed to kill you is ineffective. It gives you huge amounts of confidence that you can continue to step forward in battle. And now you can go into areas that you did not before.